In this video, you will learn how to find the location of a point after rotation of axes. Begin by graphing the ellipse given by the formula x squared over 9 plus y squared over 1 equals 1. Now imagine rotating the ellipse 45 degrees counterclockwise, which gives us a conic section with a graph that is not aligned with the x or y axis. The equation 5x squared minus 8xy plus 5y squared minus 9 equals 0 represents this ellipse. A new coordinate system could be introduced with the same origin, but the xy coordinate system is also rotated 45 degrees counterclockwise. In this coordinate system, the rotated ellipse has a major axis on the new x-axis and a minor axis on the new y-axis. We can now develop the rotation of axes formula, which will allow us to transform the second-degree equation in xy into an equation in the new xy system of a conic that is familiar to us. We will use the generalized equation ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Let the new xy coordinate system be a rotation of the xy coordinate system about the origin by angle theta. Let P equal some point at distance r from the origin. We can represent the point P as the point xy on the original coordinate system, or capital XY on the new coordinate system. Next, we will define angle alpha as the angle that r makes with the new x-axis, which means that alpha plus theta is the angle that r makes with the original x-axis. We can now represent point P in polar coordinates using the following relationships. X equals r times cosine of the quantity alpha plus theta, y equals r times sine of the quantity alpha plus theta, capital X equals r times the cosine of alpha, and capital Y equals r times the sine of alpha. Now we can derive the rotation of axes formulas. We will start with the x term and write the cosine identity for a sum. So we have x equals r times the cosine of the quantity alpha plus theta, which equals r times the quantity cosine of alpha times cosine of theta, minus sine of alpha times sine of theta. Next, eliminate the parentheses and group r with the alpha terms. So, x equals the quantity r times cosine of alpha times the cosine of theta minus the quantity r times sine of alpha times the sine of theta. Then, substitute according to the relationships. Capital X equals r times cosine of alpha and capital Y equals r times sine of alpha. This gives us the rotation of axes formula for x. So, x equals capital X times cosine of theta minus capital Y times sine of theta. We can then duplicate this process for the y term. Begin by using the sine identity for a sum. We have y equals r times sine of the quantity alpha plus theta, which equals r times the quantity sine of alpha times cosine of theta, plus cosine of alpha times sine of theta. Next, eliminate the parentheses and group r with the alpha terms. So, y equals the quantity r times sine of alpha times cosine of theta, plus the quantity r times cosine of alpha times the sine of theta. Then, substitute according to the relationships as before to get y equals capital Y times cosine of theta plus capital X times sine of theta. Suppose that the x and y axes in the rectangular coordinate plane are rotated through an acute angle theta to produce the capital X and capital Y axes. We can solve for capital X and capital Y in terms of x and y, and doing so tells us that the coordinates xy and capital X, capital Y are related according to the following equations. X equals capital X times the cosine of theta minus capital Y times the sine of theta, and y equals capital X times the sine of theta plus capital Y times cosine of theta. Or, capital X equals x times cosine of theta plus y times sine of theta, and capital Y equals negative x times sine of theta plus y times cosine of theta. Now, let's try an example. If the xy coordinate axes are rotated 30 degrees, find the capital XY coordinates of the point xy equals 2, 3. Start with the rotation formulas. Let x equal 2, y equal 3, and theta equal 30 degrees. So, we have capital X equals 2 times cosine of 30 degrees plus 3 times the sine of 30 degrees. And capital Y equals negative 2 times sine of 30 degrees plus 3 times cosine of 30 degrees. Since cosine of 30 degrees equals the square root of 3 over 2 and sine of 30 degrees equals 1/2, these equations simplify to capital X equals the square root of 3 plus 3/2 and capital Y equals negative 1 plus the quantity 3 times the square root of 3 over 2. Therefore, the capital XY coordinates are the square root of 3 plus 3/2, negative 1 plus the quantity 3 times the square root of 3 over 2.